Who are we? Where did we come from? And what awaits us after death? Humanity has spent countless ages, still unceasing, in pursuit of answers to these profound existential questions. From this quest arose the myths we inherited from ancient civilizations. Yet the torch of inquiry was carried forward by scientists and philosophers, striving to arrive at rational explanations that might illuminate the relationship between man and the world around him. This pursuit endured through the centuries, culminating in what we now call modern science, which has succeeded in addressing many of the questions that once perplexed humankind throughout its history. In the 1940s, two principal models emerged, each proposing a different account of how it all began. The first was the steady-state model, advanced by the British astronomer and mathematician Fred Hoyle. It envisioned an infinite, eternal universe, without beginning or end, neither springing from a single atom nor created in a single moment. The second model came from the Ukrainian physicist George Gamow, the Great Expansion. It posited a minuscule atom of unfathomable density, which suddenly, for reasons unknown, exploded some 14 billion years ago, giving birth to the universe, which continues to expand as a result of that primordial detonation. Hoyle believed that observational evidence would support his own theory, leaving Gamow's without foundation. In derision, he mockingly dubbed it the Big Bang, a name that, ironically, clung to the model and endures to this day, after a triumph through scientific validation. According to the Big Bang theory, the universe began as a singular particle. For reasons beyond comprehension, it burst forth with immense energy, producing the first atoms of hydrogen, which later fused to form helium. This nuclear fusion released vast quantities of light and energy, leading to the birth of the earliest stars and the spread of light across the cosmos. That very light was detected in 1965 by Arno Penzias and Robert Wilson, who for this discovery were awarded the Nobel Prize in 1978. Hoyle, however, the proponent of the steady-state model, remained steadfast in his disbelief, never accepting the very theory he himself had mockingly named. He died in 2001 still convinced of his own model, even as the Big Bang theory had by then been overwhelmingly substantiated, leaving no credible grounds for its denial. Its validity was further bolstered by the observations of Edwin Hubble, who confirmed through his study of galaxies that they were receding from one another. Additional confirmation came with the discovery and imaging of cosmic microwave background radiation by the Cosmic Background Explorer satellite in 1989, reinforcing the earlier findings of Penzias and Wilson. Wilson himself, perhaps unwittingly, revealed a profound truth when he remarked, "In many cases, when a fundamental change occurs in a scientific model, it takes a generation to accept it. I think the world is now ready to accept the reality of the Big Bang. For centuries, generations have sought the answer to the question, where did we come from? There are religious accounts in every civilization, but today we have definitive proof that we came from a great explosion." Indeed, the Big Bang theory provided the most compelling model of cosmic creation, one that science subsequently confirmed. It remains the prevailing paradigm to this very day. But what then? What transpired in the vast span of time separating our present age from that primeval explosion? What occurred 14 billion years ago that has culminated in the reality we now inhabit? Well then, let us begin anew. In a fraction of a moment, scarcely a billionth of a second, an imperceptible speck of matter expanded to the scale of a vast galaxy, unleashing an inconceivable surge of energy, the very force from which the cosmos itself was born. 380,000 years after this primordial explosion, the first atoms of hydrogen emerged, forming the foundation of the great workshop destined to forge all things. Under the immense pressures and searing heat acting upon these hydrogen atoms, new atoms of other elements began to arise. Within this nascent universe, gravity drew the clouds of gas and dust together, intensifying the heat until it reached 18 million degrees Fahrenheit, whereupon hydrogen atoms fused to give birth to a new element, helium. From this nuclear fusion, torrents of energy were released into the void as light and heat. Thus were born the very first stars, sources not only of illumination and warmth, but also of creation itself, serving as cosmic foundries where, under colossal pressure and unimaginable temperatures, atoms fused into ever more complex elements. Hydrogen transformed into helium, helium into lithium, then into carbon, oxygen, nitrogen, and iron. In this way, the first 15 essential elements came into existence. But one of the heavier elements, copper, zinc, bronze, gold, uranium, and others that no star could forge with its own heat alone. Here began the cataclysmic deaths of stars, their titanic explosions known as supernovae. In these infernos, energy surged with such ferocity that even the heaviest atoms were fused, giving rise to the rest of the elements that populate the periodic table. Over 8 billion years, the stellar foundries continued their eternal cycle. Stars ignited, lived, collapsed, and exploded, each generation leaving behind heavier elements than the last. Among these stars was our own Sun, born 4.5 billion years ago, gathering 99.9% of the gas and dust of the newborn solar system to blaze into existence. Around it coalesced the planets, each carved from the remnants of that cosmic birth. The third of these worlds from the Sun was Earth, emerging some 4.5 billion years ago as a molten sphere of volcanic rock, seething with a blend of elements. It spun far more rapidly than it does today, with days lasting but 6 hours. This furious rotation drove the lighter elements upward, forming a cooling crust, while the heavier elements sank inward, creating a core of iron and nickel. From this heart arose Earth's magnetic field, shielding it from the Sun's lethal radiations, anchoring the atmosphere, and laying the foundation for life. Yet catastrophe struck when a massive celestial body, hurtling at 40,000 kilometers per hour, collided with a young Earth. The planet absorbed the intruder, but the scattered debris continued to circle in orbit. Gravity slowly drew these fragments together until they merged into a luminous companion, the Moon, that silver sentinel which has graced the skies ever since. That cataclysmic collision also tilted Earth upon its axis, bestowing upon it one of the greatest gifts to life, the succession of the 4 seasons as the planets circled the Sun. Meanwhile, the Moon itself became a vital ally in the story of existence, its gravity gradually slowing Earth's once frantic spin, tempering its days into gentler rhythms. In its infancy, Earth was searingly hot and devoid of water, though its atmosphere brimmed with vapor. As the surface cooled, the vapor condensed and fell as rain, filling the basins to form seas and oceans. Some 3.8 billion years ago, beneath those primeval waters, hydrogen, oxygen, carbon, and nitrogen fused into a singular marvel, deoxyribonucleic acid, DNA, marking the dawn of life. This first living entity, a humble yet enduring presence, was bacteria. Feeding upon sunlight, it produced as its byproduct the very breath of life, oxygen. The seas carried iron in abundance, dissolved and mingled within the newborn planet. As bacteria consumed sunlight and released oxygen, a profound transformation began. Oxygen in the water bound with iron, forming rust, iron oxide, that sank as hardened deposits into the depths, leaving behind the iron or upon which humanity would one day depend. When the oceans no longer held sufficient iron to absorb it, oxygen began to seep upward, filling the atmosphere. For the next 2 billion years, life in the waters grew ever more complex. The skies turned blue, and the land rose as a single vast supercontinent, Pangaea. As oxygen in the air reached 13%, the Cambrian explosion was ignited some 550 million years ago. In its wake appeared the first marine creatures, which, through countless mutations and the slow march of evolution, gave rise within 50 million years to the first bony fish, the distant ancestors of humankind. By then, plants and trees had already begun to flourish upon the land. 400 million years ago, vertebrates of the seas were ready for a momentous leap. Amphibians crawled forth to claim the solid earth as their new home. Yet they remained tethered to the waters, for their delicate, gelatinous eggs withered on land. Some, however, solved this conundrum, encasing their offspring in hardened shells that preserved the life-giving moisture within. Thus amphibians gave way to reptiles, severing their final bond with the sea and venturing far inland to colonize the continents. Then, 250 million years ago, Earth was convulsed by the greatest volcanic upheaval in its history. Carbon dioxide engulfed the skies, extinguishing more than 70% of the living forms that had arisen in the Cambrian. This epoch came to be known as the Permian extinction. Extinctions, it seems, were the crucibles of renewal, reshaping life's course. Again and again, annihilation cleared the stage for new creatures to dominate, while others vanished forever in evolution's relentless tide. Dinosaurs came to rule for more than 160 million years. During their reign, forests spread, the day settled into its present span of 24 hours, and Pangaea fractured into continents. Beneath their colossal shadows, mammals lingered, small and obscure. Yet 65 million years ago, a celestial rock 6 miles across struck the Earth with apocalyptic force, wiping out every creature greater than 50 tons. The age of dinosaurs ended, and in their absence, the mammals emerged to ascend the throne of life. It was not long after the extinction of the dinosaurs that the first true primates emerged, creatures that dwelled among the trees until some were compelled to descend to the ground in search of new habitats, as grass swept across the land and food grew scarce. Over time, these primates learned to stand upright upon their hind legs, rising above the grass to watch for predators. From there, they began to move upon 2 feet, freeing their hands, the very hands that would one day shape the course of human history. Thus did the earliest hominids tread the earth more than 2.5 million years ago, before they learned to think, to shape stones into spearheads and tools, heralding the dawn of the Stone Age. Humanity then discovered fire a mere 100,000 years ago, by which time it had assumed its present form, far removed from its simian ancestors. With fire came speech, the weaving of complex sounds into words, communication, and the sharing of knowledge. Intelligence grew. Humankind spread across the continents, and in time, even reached the moon. Yet 50,000 years ago, the Ice Age swept across the globe, a harbinger of extinction. Still, humanity endured. It spread, its ingenuity, and its intellect shielding it from annihilation. It multiplied, advanced in science and knowledge, and carried its steps ever upward. But consider this, if our history began more than 14 billion years ago, what then is the span of humanity against the age of the cosmos? Imagine the entire age of the universe, 14 billion years. Compressed into 14 years, humanity's life would amount only to the final 3 minutes. And what, then, is the lifespan of a single human compared to the life of the cosmos? We are nothing, mere dust upon the wind. And this, they say, is what we must understand, that we are children of a great explosion, a pure accident, descended from a fish that evolved. What meaning, then, has life? What worth do we possess? And how are we to believe that there is a God who created us, who fashioned the heavens and all things for our sake? What do you make of this tale? Does it not resemble one of those works of speculative fiction? Do you not wonder from whence the scientists drew these stories and figures? And why they speak with such certainty of the birth of the universe, of life upon the earth, and of evolution itself? Perhaps your mind drifts to the inheritance of faith, to the words of the Almighty in the noble verse, "I did not make them witness the creation of the heavens and the earth, nor the creation of themselves, nor did I take those who mislead as helpers." These are the sanctioned scientific theories which declare that the universe came into being by chance, that no creator fashioned humankind, but that man simply evolved from bacteria to fish to ape to the fully conscious, reasoning being we are today. Are you persuaded, even apart from any religious evidence? Do not hurry your answer, for our journey has scarcely begun, and stranger, more astonishing things yet await. Remember this well. These are not fables of our own making, but the theories of great men of science, embraced by the world and taught to us in our schools. Hold it in mind, for we shall need it as we venture further into this extraordinary voyage.